Hello everyone, and thanks for joining this session titled Learn How Personalized Marketing is Advancing with New NVIDIA Technologies. My name is Anthony Wintheiser with Antuit AI, and over the next 30 to 40 minutes, I'd like to walk you through an overview of how personalization is used today, how it has evolved over the last several decades, and what we believe is the #1 challenge that prevents leading brands and marketers from delivering world-class personalization that delivers relevant customer experiences and accretive business results. After that, I'd like to walk you through how we've helped solve this challenge. I'll highlight some of Antuit AI's recent innovations in personalization and deep dive into a specific use case where we'll get into the weeds on the underlying data science that enables it. We'll then switch gears and talk about personalization. In this section, we'll walk through some use cases that we believe will be possible soon, along with some of the challenges that need to be overcome for them to become reality. In this context, we'll also highlight some of the underlying data science and engineering that will power these futuristic experiences. Let's start by talking about the ubiquity of personalization. Personalization is all around us, from the content that we're recommended when we binge watch Netflix, to the products and categories that we see when we late night shop on Amazon, to the ads we're served when we catch up with friends and family on Instagram. Personalization is all around us and pervasive across all analog and digital channels. If we take a look at how we got here, personalization is just the latest stage in the evolution of marketing to become as precise as possible in its ability to target consumers, engage them in relevant ways, and influence their behavior. This journey started with mass marketing in the age of mass media. Mass marketing focused on driving reach to maximize brand awareness, and at this time there was little consideration for who saw what message. The industry evolved from mass marketing to macro segmentation, where brands started to target consumers using broad demographic variables such as age, gender, and geography. Macro segmentation is still alive and well in many analog channels today, such as TV and print. The next stage in evolution was moving from broad, univariate, and relatively inflexible macro segmentation to narrower, multivariate, and nimbler micro segmentation that did an even better job of aligning message, content, offers, and brand value to consumer interests. Microsegmentation is the norm today for most digital or addressable channels. As we look to the future, the next stage in the evolution of personalization will be focused on what we call outcomes-based one-to-one marketing, where multiple data inputs are used to engage individual consumers in a unique way that is calculated and optimized by algorithms. There are two key concepts here that are worth unpacking. The first concept is one-to-one, where marketers move from engaging with segments or cohorts to engaging individuals. Personalization will become individualization. The second key concept is the idea of outcomes-based or outcomes-optimized marketing, where the target end results drive all the execution-oriented decisioning. More on this later. So to recap, personalization has come a long way. Unfortunately, it still has a long way to go. This is because of a pervasive gap between customer expectations and the reality of the customer experiences being delivered today. In 2016, a McKinsey survey found that 85% of consumers wanted personalized experiences, but only 23% thought retailers were doing a good job at delivering them. 2 years later, in 2018, another survey, this time from Accenture, found that 80% of consumers said personalization was important to them, but only 20% of consumers said retailers were doing a good job at it. Fast forward another 2 years to 2020, and another survey, this time from Boxever and YouGov, finds that 73% of consumers expect brands to understand their needs, but only 22% are satisfied by the personalization they get. There's a problem here. Despite the tremendous amount of invention and innovation over the last 5 years in media buying, creative development, and experience orchestration, personalization seems to be frozen in time and unable to bridge the chasm between what customers want and what customers get. How is this possible? While there are a number of challenges and limitations, if we boil it down to its most basic, we believe that one of the key constraints to better personalization is that for the most part, the ecosystem is built around putting the marketer at the center of all marketing decisioning. The marketer is responsible for designing the loyalty program structure and rewards, building brand offers, targeting CRM messages, planning paid digital and social media advertising, mapping the customer journey and engagement touchpoints on digital commerce channels, and allocating investment in emerging technologies such as smart assistants, just to name a few priorities on their to-do list. While the tools to facilitate and enable these activities has improved and processes have been streamlined, the basic paradigm of the marketer being at the center of the decision-making process hasn't changed in decades, and we believe this is a huge bottleneck. To bring this to life, let's look at a brand's relationship with an individual customer and how it changes over time. If we look at an individual customer over time, we see that they continuously migrate between life cycle stages. When they start out, they're new. If all goes well, they become regular or active customers. While active, they'll go through phases of increasing or decreasing engagement, and at some point, they may lapse and then re-engage. Over the course of time, their responsiveness to different marketing intents will change, as will their engagement across different channels. Some of this may be driven by changes in actual or perceived brand value, while some may be driven by life cycle stages such as getting married, having children, moving, or retiring. Not surprisingly, their purchase behavior across categories and items will also change over time. That's a lot of change to keep track of, and it only gets more challenging from there. When you cross changes in all of these with the channels that a brand might engage a customer on and the business objectives that marketers want to achieve, the number of potential customer interactions is over 1 billion per day. With over 1 billion potential customer interaction combinations per day, how likely is it that a marketer will pick the right one? Even with all the targeting and segmentation tools that are available today, the odds are pretty small. If that's not discouraging enough, extrapolate this challenge across a brand's entire customer database. If we look across an entire customer database, we go from 1 billion potential customer interaction combinations to over 10 quadrillion potential customer interactions that need to be decided on a daily basis. Hopefully this brings to light, and should be clear by now, that an ecosystem built around putting the marketer at the center of all decisioning will not take full advantage of the data and the opportunity that a brand has at its disposal to engage with customers. Only artificial intelligence and machine learning decisioning at scale can optimize customer engagement at the individual level in a contextual and outcomes-based way. Used the right way, artificial intelligence and machine learning can deliver the next step in the evolution of personalization on what we call programmatic personalization. While traditional personalization, which has been the norm for the last 20 years, is best described as marketer-led, input-oriented, and tactic-focused on segment-level activation, with the result being dilutive impact with limited measurement and feedback, programmatic personalization is the complete opposite. With programmatic personalization, the marketer focuses on strategy instead of tactics and leaves the decisioning to the machines. Programmatic personalization focuses on one-to-one activation instead of reaching cohorts and segments, and is proven to deliver accretive impact powered in part by continuous measurement and learning that enables ongoing optimization. In many ways, programmatic personalization mirrors some of the best elements of programmatic advertising in that it leverages multiple data sources, cloud-based technologies, and algorithmic decisioning at the customer level to deliver dramatic improvements in efficiency and effectiveness. This is the future of personalized marketing that can be enabled in part with NVIDIA technologies. What does this look like in action? If we take an ad tech or MarTech view of things, what happens is that we insert an intelligence layer between marketers' data and activation layers. The data layer will typically be some kind of enterprise data warehouse or customer data platform, and the activation layer will typically be a marketing cloud or cross-channel campaign management platform such as Salesforce, Adobe, Oracle, or Marcus. The intelligence layer will ingest the raw data from various sources and turn it into an intelligence feed that directs the activation layer on who to engage with what message, when to engage them, and on what channel to accomplish a specific business objective. The intelligence layer is entirely cloud-based, and within it, several algorithms will run independently or codependently to set customer-level strategies, build the perfect interactions, forecast outcomes, measure results, and integrate observed differences for optimization. We'll unpack this in more detail in 2 slides, but before we do that, it's important to highlight a few key innovations that are baked into this approach that make programmatic personalization a reality. If we look at recent advances on the road to programmatic personalization, which is the bleeding edge of one-to-one, we see a few key innovations over the last few years that have made it possible. The first innovation is one-to-one at scale, where brands can now deliver individualized content and offers across multiple channels with reach and conversion that is multiple times above benchmarks. One-to-one engagement typically has an inverse relationship with reach and conversion, so cracking this was an important first step. The second innovation is outcome automation, where brands use artificial intelligence and machine learning models running on cloud infrastructure to automate decisioning, learning, and ongoing optimization against specific, pre-specified business outcomes. This innovation provided the autopilot capability to marketers for the first time. The last innovation has been in enabling omni-strategy execution, where a brand can algorithmically execute and optimize across multiple strategies and tactics that run simultaneously. This last innovation enables the marketer to focus almost exclusively on strategy and step back from tactical execution. Over the last 4 years, we've developed, deployed, scaled, and successfully managed increasingly valuable and accretive decision engine and measurement capabilities. We're excited to lift the hood on some of them today and discuss implications for the future that are possible with some of the new technologies coming out from companies such as NVIDIA. As we deep dive into a specific use case, before we get to algorithms and infrastructure, it's important to highlight that data integration and transformation is the first step to enable decision intelligence at the individual customer level. In a typical engagement, the platform collects, integrates, cleanses, and harmonizes disparate data sets from first, second, and third-party data sources. Data collection typically spans common online and offline data sources such as profile, transactional, behavioral, interaction, and product data. Most enterprise brands will have multiple terabytes worth of customer and product data that will feed into our systems. As the platform collects the individual customer data, it is cleansed, integrated, and sequenced into what we call a living record. After that, we apply feature engineering to shred the data and create a large library of new modeling variables. To bring this to life, for a restaurant client, we might shred their menu data and transform a turkey sandwich data point into new data points that include oven-roasted turkey, applewood smoked bacon, and smoked Gouda. For a retail apparel client, we might shred their data and transform a black dress data point into new data points that include an off-the-shoulder neckline, gray bodice, and peplum. The output is a genome with thousands of variables that provide a living and evolving understanding of the customer at an atomic level. It also provides rich inputs into the various models that we use, which we'll cover on the next slide. Building customer knowledge is only the first step in a multi-step AI-powered process that identifies loyalty-building decisions. After we build customer knowledge, the next step is to model behavior propensity, where we use factorization machines to model behavior preference for each customer and map it to a universe of potential future actions. The step after that is to estimate activity conversion given a specific type of engagement. Here, we use decision tree ensembles to model the likelihood of driving a target behavior for each customer engagement combination. This includes not only estimating activity conversion, but also the buyer effects resulting from that conversion. The next step after that is to optimize to business goals. In this step, we use mixed integer programming to identify the optimal final allocation across customers and engagements that factors target objectives, business rules, and engagement profitability. Once we have an output file, we use engagement variables to optimize channel and timing to maximize the likelihood of driving the target behavior. All of this is baked into the intelligence feed that then goes to the activation layer. Once activated and upon data collection, we measure the behavioral effect. In this step, we use gradient boosting machines to measure actual outcomes and compare to predicted outcomes in an automated self-learning process that feeds back into the modeling process. Now that we've lifted the hood on some of the steps and techniques used in modeling, let's dive deeper into a specific step by looking at how we model behavior propensity. For behavior propensity modeling, we chose a factorization machine-based architecture so the model could learn to rate unseen customer behavior combinations. One of the main challenges in personalization is modeling behavior for a customer that has no history of engagement with a specific vector or item. We've found that factorization machines are one effective way to solve that. We took our approach a step further with universal ranking and primarily used PySpark and TensorFlow to design our final solution. The reason why universal ranking is important comes later on in the process where we optimize against a specific outcome. Unlike most recommendation algorithms where the only recommendation that counts is to the customer, we also need to rank customers to other customers when determining who to engage with what experience. As a result, we needed a mean square error loss function. Customer features included what the customer had purchased in the past, while behavioral features included product attributes or other attributes related to the behavior being predicted, such as order channel, daypart, and category. To train the model, we excluded random behaviors from the customer feature set and tried to predict them. The model was validated by removing a random subset of customer behavior interactions and comparing actual versus predicted ratings within a test set. The customer behavior ratings were defined by univariate clustering log of customer behavior spend across customers for each behavior into 5 clusters. On the slide here, you can see the total training data size, number of parameters, over 3 billion predictions, and total training time of 4 to 6 hours. At the end of all this, our mean absolute error came in at 0.73, which we felt was sufficiently accurate for deployment. We have since proven in market that this is correct. A few technical hurdles worth highlighting relate to the size of the data being processed and the model tuning involved in optimizing the algorithm. Regarding size of data, in order to implement this across tens of millions of customers, which will be a common occurrence for enterprise deployments, model data was written into batches of Parquet files and model parameters were shuffled in order to work within a single GPU. In the future, we believe that this can be solved more efficiently by using deep learning frameworks such as Merlin or Horvath. Regarding model tuning, because some customer behavior occurs less frequently than other customer behavior, sample weights needed to be tuned proportionally. For this particular instance, we used L2 regularizers on model parameters, as well as an activation L2 regularizer on the output embedding vectors in order to reduce model overfitting. If we take a look at the data engineering side of things in this instance, we use Google Cloud Platform to run our training and allocation jobs. At a high level, we use Airflow to schedule jobs, and each job runs on an ephemeral data proc cluster. We manage our code base in Git, and each release updates Airflow DAG code and the code our data proc clusters run. All the data on GCP physically resides in Google Cloud Storage and is stored as Hive tables. We have jobs set up to copy data from the external EDW client database into Hive tables on GCS, and consequently to export the allocation results back to EDW, which in turn gets sent to the marketing and loyalty clouds downstream. We train the models weekly in a series of steps that you can see on the slide. Each step is executed on a data proc cluster running N1 high-mem 16 nodes, specifically 16 virtual CPUs with 104 gigabytes of RAM, where the number of nodes depends on the step. This provided us with a good balance of performance and price. For the factorization machine's job, we also attached an NVIDIA Tesla P4 GPU to the cluster. The daily allocation job uses model training outputs and runs on a data proc cluster with 11 N1 high-mem 32 worker nodes, specifically 32 virtual CPUs with 208 gigabytes of RAM. Here we execute all the steps from modeling customer lifecycle stages, which takes about 10 minutes, to all the steps in the offer allocation, which takes about 40 minutes. During this process, we are regularly crunching through over 2 terabytes of transaction-level data to compute customer features. The last step is to create the final output file that provides directions for the orchestration layers and is sent to the EDW. Hopefully that was a helpful deep dive into one of our active deployments on the leading edge of personalization. If we switch gears and think about what the future might have in store, our minds might go to John Anderton in Minority Report, whose identity is confirmed via retinal scan and is then presented with holographic advertising for Lexus, Bulgari, and Guinness as he walks through a mall concourse. Some of our minds might instead go to the Black Mirror Nosedive episode, where Lacey Pound is presented with a holographic placement of herself making a meal with her partner in the kitchen of an upscale condo that she's looking to lease. While these use cases are still science fiction today, many of the capabilities that will enable them are close to fruition. Three interrelated use cases that borrow in spirit from the science fiction of Minority Report and Black Mirror are real-time individualization, digital clienteling, and augmented reality. Real-time individualization is all about individualized experiences that are personalized based on processing of real-time variables and customer inputs. This happens to a limited extent in digital advertising and digital commerce today. Digital clienteling is all about an in-store experience where store associate expertise is augmented or entirely replaced by various digital technologies to improve the ease and value of clienteling. Some promising initiatives have been trialed at a few specialty retailers today. Lastly, augmented reality is all about the creation of a fully digitized audiovisual experience in real time based on historical and streaming data inputs. This is the farthest out of the three and highlights ongoing pain points that personalization has in leveraging and dynamically creating content at scale. While there are several challenges that stand in the way of broader adoption and use case deployment, a few important ones worth mentioning are the need for improvements in 5G connectivity, edge computing, customer identification, gesture and voice recognition, and augmented reality. If we spend a minute on the technology challenges and the five that we've highlighted here, 5G connectivity is important for effective load balancing of data computation and hardware needs. Edge computing is going to be important for individualized, intelligent customer engagement with zero latency. Customer identification is going to be important for privacy-compliant access to past transaction and engagement history. Gesture voice recognition is going to be important for a faster, more natural, and more valuable human-machine interaction. And lastly, augmented reality is going to be important for more engaging and more valuable customer merchandise interactions. The data engineering stack of the future in many ways is similar to what leaders might use today. Running in a cloud environment, leaders might continue to store data in Google Cloud Storage, use a tool like Airflow to schedule jobs, and run jobs and allocations on data proc clusters. What would be very different is the last mile of customer engagement. As personalization leads to individualization, and as asynchronous decisioning leads to synchronous or real-time decisioning, we see an increasingly important role to be played by incorporating auto-scaling GPU-enabled instances that can load balance and instantly fulfill concurrent API calls across multiple channels, such as point of sale, kiosk and smart mirror, drive-through and pickup, digital commerce, and beacon or location. With the broader infrastructure challenges around connectivity, identification, interaction, and delivery in place, this final link creates the possibility for contextual intelligence at scale that is individualized and rendered in real time across any customer touchpoint. From a data science perspective, we see a lot of near-term opportunity with techniques such as reinforcement learning that will allow us to optimize to a broader action space and better quantify the effects of engagement over time. Reinforcement learning uses state spaces crafted to analyze what the present relationship of a customer is with the business, as well as features of different actions. In this illustration, the view is simplified into state clusters, but under the hood, we can map to an infinite amount of possibilities. By learning from historical event sequences, reinforcement learning will allow us to evaluate which actions lead to maximizing different business objectives over the short, medium, and long term based on the present state space of the customer. We believe this will be as valuable of an innovation in programmatic personalization as was the innovation in migrating from single objective optimization to multi-strategy and tactic optimization. To wrap up here, we believe the business impact of personalization is hard to understate. There's a big gap between what customers want from personalization and what they get. 80% want personalized experiences, but only 20% are satisfied with the personalization they get today. Even with that state of affairs, the impact of personalization on customer behavior is undeniable. A recent BCG Google study found that personalization increased the number of items purchased by 110%, the average order value by 40%, and a brand's net promoter score by 20%. Imagine the effects personalization can have when executed individually, contextually, and programmatically. That's our session. Thanks for attending. I hope it was valuable and insightful, and I hope everyone has a great rest of the day.
All right, hey everyone. That's the presentation for this session. We're going to get to the Q&A here in a little bit. So for those who want to submit a question, give you a minute or so to get in your questions. We've already got a few coming in from the audience, and we'll get to them in just a bit. Okay, so let's start getting into some of the questions that have come our way. The first one here, Kyle, I think this might be a good one for you. Can you talk about, so the question from one of the members in the audience is, what was the most challenging data science aspect of building the multi-step decision engine? Can you talk about that one for a little bit?
Hey, yeah, thanks, Anthony. I guess the most challenging part was one on the technical front of working with the massive amounts of data and basically trying to fit millions of customers' embeddings in memory. And then the other piece was basically I had to kind of rack my head for a while around customer interactions that were more sparse. So the model wasn't learning those very well because it wasn't seeing it very often in training. So that's where using those sample weights really helped boost the model in learning.
Awesome. Thanks, Kyle. Okay, the next question here, I think this will be a good one for you, Vlad, from another member in the audience. Can you talk a little bit more about what sounds like the machine learning, the ML engineering side of the solution, and talk more about how we're able to crunch multiple terabytes of data and generate billions of predictions in the tight runtime that we have?
Yeah, sure. Hi, everyone. So I guess that comes down to a proper hardware configuration as well as the right software approach. On the hardware side of things, we utilized these Spark clusters with a sufficient amount of memory. And on the software side, it comes down to using vectorized data frame operations and keeping data to the minimum needed for the processing. So the combination of these allowed us to tune it to to the state where we could run it in a pretty short time frame for our needs here.
All right, thank you, Vlad. So the next question that we have here on the list, switching to a slightly, I guess, less technical question, is from another member of the audience, where we have, what kind of benefit have you seen in moving from a segmentation-based approach to an individual-based approach for targeting? So I'll get into that one on my end. What we see at a high level, when we're comparing our performance, we're looking at a few different KPIs. Obviously, since our focus is on business outcomes, and we're typically working within the context of messages and offers, we're really looking at KPIs such as redemption rates, discount per redemption, efficiency as measured by sales relative to discount, and things like that. And so when we compared, our latest version of our engine to the first version of the engine, what we saw in the first run that we did was, one, we were able to improve the redemption rate by almost 2x relative to where it was initially. So initially, we were already at a benchmark setting number. With the latest version of the engine, which we kind of walked through today, we were well in double digits and almost 2x of where we were before. And we were able to drive that higher redemption with a much lower cost per offer, 35% lower cost per offer. And so from an efficiency perspective, we were able to improve efficiency by more than 2x. What I think is important to highlight is, when we were comparing our performance relative to prior versions, we were comparing an individualization approach to an individualization approach. And so I think with the combination of data science and machine learning engineering that we've talked about here, within the context of individualization, there's a lot of room for improvement. But to get to the question specifically around how individualization is better than segmentation, what we've seen comparing to those benchmarks is that typically we're anywhere from 10x to 15x higher across measures that would tie to efficiency or effectiveness. So there really is a pretty big gap in performance between the two that does justify the increased investment in data science, computational capabilities, the engineering that goes behind it to enable it. In every deployment that we've had, we've seen that kind of benefit from switching from one to the other. So hopefully that provides a little more context there. The next question from a member of the audience is, and Kyle, this might be a good one for you, and then maybe I can chime on top of it. Can you please elaborate more on using reinforcement learning? Would you just use reinforcement learning for product recommendations, or would you use it more broadly for, let's say, personalizing content, the messaging, the channel when interacting with the customer?
Yeah, I think the idea here is, like what we're thinking is less of the product recommendation and more of what they said about choosing the right content, messaging, and channel when interacting with the customer. And basically, our goal is to optimize those customer touch points.
Yeah, I agree with that. But based on what we've seen, we obviously can take a number of different approaches to how we would, model customer behavior. Reinforcement learning can not only help with figuring out what is that ideal offer or content within a message more broadly, but similarly, the same type of approach can be used to optimize the channel that it's deployed on, the timing that it's deployed on. And I think, as we look toward the future, right now a lot of the conversation today is really in the context of single interaction, single point of touch optimization. As we look towards the future and start playing around more with optimal sequences for a customer given where they are in their relationship with a brand, that's going to be another area where reinforcement learning is going to help us polish off the hypothesis and the execution from there. Okay, so we've got another question here. This is a good question around how the data gets transferred. Obviously, the output from the decision engine, which is key at the end of the day. If we're not able to, seamlessly inject the intelligence from the platform into the activation layer, whatever that may be, there's no value that's going to come from it. So the question specifically is, how do you pass the model's output to marketing vendors like Google, Facebook, et cetera? And in this case, we're talking about Google and Facebook, but conceptually, it could be a marketing cloud like an Adobe or Salesforce, like we talked about. It could be programmatic, DSP, demand-side platform, if we're doing programmatic advertising, or any other one. But Vlad, do you want to talk a little bit about that last mile connection between where our engine outputs and how we might plug into a Google or a Facebook?
Yeah, sure. So once we process the daily allocation and generate a recommendation per customer, we then just generate it as a action table and pass it downstream. And in this case, like Anthony mentioned, it could be something like Adobe Marketing Cloud. So then once it lands in that team's area, it just gets picked up and actioned by that cloud to distribute the messages. And in parallel, that allocation data also gets pushed to the to the system that actually loads the offers to people's loyalty cards to use the rewards.
Yeah, and so building on that, for Google or Facebook specifically, depending on the nuances of the execution, so let's say we're in this asynchronous setup where every day or every evening we decide, what our marketing activities are going to be for the next day. What we would do with Google or Facebook is have a file transfer in place where every night we would port over information on, what customers we want to reach, along with all the other information associated with that customer. So it could be a reference to a creative that needs to be pulled from a different file. It could be a reference to a bid if there's some kind of real-time bidding going on, and other parameters related to that execution. And so, I think is embedded in what Vlad said is that the data template or format that is the backbone of that transfer is going to be different for Facebook. It's going to be different for Google. It's going to be different for an Adobe or a Salesforce. But part of what we do, being an agnostic omni-channel enabler, is we'll establish those templates with each of those partners that the client wants to engage, and then spin out the output in that template so it can seamlessly and automatically feed through.
Yeah, and maybe just to add a little detail to that, it's not like a one-way road. So obviously, once it's pushed, we then collect the interaction feedback from those systems to use in potential extra feature engineering around customer engagement.
Cool. All right. So the next question here is around propensity. So we had one slide where we're talking about the number of calculations that we're running with each batch. So the question that we have here is, how many propensities are you predicting per customer? how are these then aggregated into a decision that should be actioned? Kyle, do you want to take this one?
Yep, thanks, Anthony. So the amount, I guess it depends on the actual use case that you're doing, but like what we've seen is it could be hundreds to thousands of different propensities, generally somehow tied to like the different customer behavior. So it could be like a time of day that a customer is engaging, or like specific products or categories, or basically any kind of attribution you can do about purchaser engagement. And then what these actually are fed into is a gradient boosted tree-based learner that kind of acts as a ensemble of those engagement propensities and some other features that are derived. And then that basically calculates kind of a aggregated propensity for the specific piece of content that we're attempting to predict for.
Yeah, so on that one, Kyle, the number of propensities that we're predicting per customer, tell me if I'm right, is going to be largely influenced by the different types of behaviors and, let's say, the number of products or items in a catalog. And so in that sense, if we're working with a specialty retailer that has a few hundred items or SKUs in their catalog, we're going to be calculating a much smaller number of propensities per customer than if we're working with, let's say, a grocer that typically has 45,000 SKUs per location. Is that a reasonable way to think about the number of propensities per customer?
Yeah, exactly.
Okay, great. All right, so then the last question that we have on the docket right now, if anyone else wants to get any questions, please feel free to do so. We do have a few extra minutes here. Last question, very interesting one here, and it is, do you think highly targeted marketing, as you've described it here, is beneficial from a society point of view? What is the price the customer has to pay when you're able to increase the money spent on a website by 40%? I think that's a great question. Minority Report and the Black Mirror example that we talked about earlier aren't necessarily the most positive or reassuring. Our point of view, my point of view specifically, is that it is beneficial from a societal point of view, in the sense that what we've built is a platform that allows marketers to identify what is the most relevant way to engage a customer, which in turn allows them to also identify what are all of the irrelevant ways in which I should not engage with a customer. And I think if you think about the world we live in, whether we're looking at our email inbox, whether we're scrolling through our social media accounts, whether we're flipping through a magazine or TV, there are ads everywhere. We're always being bombarded with marketing and advertising, promotions and offers. And at the end of the day, there's a lot of volume, but not a lot of relevancy. And so there's also societal fatigue in the sense that our brains are always being bombarded by messages that are not relevant. And so if we can put something out into the world that helps marketers identify what a customer is truly interested in and only engage them on those elements, hopefully will reduce some of that noise and allow customers to have a clear understanding of what a brand might offer to them that is valuable. At the end of the day, the goal is not to try and extract every possible dollar from a customer. It's to build more meaningful relationships between customers and the few select brands that they choose to interact with because they are relevant, because they provide value to their lives. Kyle Vlad, I don't know if you have any other comments that you wanted to add to that, but that's kind of been one of our driving principles here from the start.
Nope, I think you summarized it well.
Okay, great. So that's all the questions we have for this session. I want to thank everyone for joining us for the session at GTC. This session will be available on demand in the session catalog within 24 hours. I hope everyone has a wonderful day. And again, thank you for joining us. Bye.